Coding and decoding. What is coding and decoding? Coding and decoding basically involves sending out information in a coded manner to someone so that the people involved in transferring this information are not able to understand it. However, the person to whom the information is transferred is able to decode it using some reasoning tricks. Now let us have a look at English alphabet and the positions of the letters in the alphabetical order. English alphabets are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Here, A, E, I, O, U are called vowels. The alphabets other than vowels is called consonants. That is B, C, D, E, F and so on. Now let us see the positional values of letters in the English alphabets. Here the numbering starts from left hand is called forward order. Now let's see the positional values of letters in the English alphabets. Here the numbering starts from right hand is called reverse order. Now let us learn about different types of coding and decoding by taking the word table as an example. Shifting the position forward. In this form of codes, every letter in the word is represented by another letter. The word is table is written as U, B, C, M, F. The logic behind this kind of coding is shifting of letters. In this case, letters have been shifted in the forward direction. The letter T is shifted to U, the letter A is shifted to B, and so on. So each letter has been shifted to its next letter in the alphabetical order. In a similar manner, letters can be shifted forward by 2, 3 or even more positions. Shifting the position backward. This coded form is very similar to the previous one because once again shifting of positions has happened. Only this time letters have been shifted backwards. The word table is written as S, Z, A, K, D. The letter T shifted to letter S, the letter A shifted to letter Z and so on for the remaining part of the word. As you see, each letter is shifted to its previous letter in the code. Similarly, letters can be shifted backwards any number of positions. Alternate shifting form. The logic behind this kind of coding is shifting of letters. But here, both forward and backward shifting are involved. The word table is written as S-B-A-M-D. Here we can observe that T is shifted backwards to S. On the other hand, A is shifted forward to B. So the first letter has been moved backward while the second letter has been moved forward. Similarly, for the third and fourth letters, B and L shifted to A and M respectively. Position-based increase. The word table is written as U, C, E, P, J. Now we can observe that T is moved ahead by 1 position to U. A is moved ahead by 2 positions as it becomes C. B is moved ahead by 3 positions and it becomes E. L becomes P as it is moved ahead by 4 positions and finally E shifted by +5 as it becomes J. Here, each letter has moved ahead in the code by the number of positions depending on its position in the word that has been coded. Therefore, the increase with every position can vary in patterns too. Numeric position in alphabetical order. In this type, the word is coded as a number which denotes the positions of the letters in the alphabetical order. The word bad is written as 214. We know B comes second in the series of alphabet, A comes first, D comes at the 4th position. All these numbers are simply written in the same order and this code is achieved. Similarly, any word can be coded by adding value like 1, 2, 3 and so on to its numeric position in the alphabetical order. Reverse alphabetical order. The logic for this code is very similar to the previous one. As the name implies, the letters in the code are those letters which are at the same numeric position when the reverse alphabetical order is taken. The word table is written as G, Z, Y, O, V. So as per this method of coding and decoding, T comes at the 7th position in reverse order, and therefore it becomes G. A comes at the 26th position, and therefore it becomes Z. Similarly, B becomes Y, L becomes O, and E becomes V. Numeric positions in reverse alphabetical order. The word try is written as 792. Given code numbers suggest the position of the letters in the reverse order. So as per this method of coding and decoding, Z becomes 1 and A becomes 26. Try is equal to 792. So if we know the positions of letters in the alphabetical order, it becomes easy to find their position in the reverse order. Sum of positions. The word table. This kind of coding is very interesting. The 5-letter word is reduced to a 2-digit number. It is actually the sum of positions of the letters in alphabetical order. Table is equal to 40. Adding the numeric positions of these alphabets, we get 20 plus 1 plus 2 plus 12 plus 5. That equals to 40. Similarly, any word can be coded by adding up the position values of the letters in the word. Coding of a word in a sentence. In this type of coding questions, generally 3 or 4 sentences or words are given with sentences or words containing codes. We just have to check for the common words, letters in the sentence, words, and corresponding common words, letters in the codes to get the answer. For example, he is working is coded as PA, LX, QW. Working for future is coded as LX, SD, ZY. From this, we can analyze that the only common word is working and the only common code is LX, which means that LX is the code for the word working. In such cases, the codes are not seen at the corresponding positions but for the common words. Symbol-based coding. In this type of coding questions, generally a word is coded in symbols or a group of corresponding symbols to letters is given. We need to identify symbol for every letter in the given word. For example, if radar is coded as star, question mark, star, question mark, hash, and door is coded as question mark, percentage, percentage, hash, then how road will be coded? So in this question, the coding of words is given in symbol form. So we need to first decode and understand which symbol represents which letter. Now, radar is coded as star, question mark, star, question mark, hash. There are 2 R's and 2 A's in radar. And in code also, there are 2 stars and 2 question marks. So it is very clear from this that D is equal to hash. Now let's take the next word. Door is coded as question mark, percentage, percentage, hash. There are 2 O's and 2 percentages. So O is equal to percentage. D is already decoded as hash. So the remaining alphabet is R and its symbol is question mark. Therefore, R is equal to question mark. As R equal to question mark, so from radar we can easily draw a conclusion that A is equal to star. Therefore, code for the word road is equal to question mark, percentage, star, hash.